Check it.
Okay, let's go over the practice quiz. First question here says solve each equation and check your solutions. When they say check your solutions, they don't really mean like check to see if you got the answer right. They're really saying check to see that your answer doesn't violate the domain of the logarithm. So you're going to plug your answer back into each logarithm and make sure you're not taking the logarithm of 0 or the logarithm of a negative number. So let's start off with number 1 here. Now for number 1, you got logs on both sides. They're both base 10, but you can't drop the logs because there's that 3 right here, right? You got to get this out of the way first. So the way to get this out of the way is to use the power property in reverse, bring that 3 up here, and then it's not here anymore, right? Once you do that, you have a log base 10 equal to a log base 10, and now you can drop the logs. So you get 27 equals x cubed. Well, we all know that 3 cubed is 27, so x is 3, but the way you get that is by cube rooting both sides, right? And you get 3 equals x. So x equals 3. Okay, now we're going to check that. I boxed it already, but we're going to check that. Do you have to plug the 3 into here? No, because there's no x. Do you have to plug the 3 into here? Yes. But if you're taking a log of 3, it's fine. It's not a negative number. It's not 0, so you're good. So that's it. That's checked. Okay, next question, number 2. Log base 10 plus log base 10 equals log base 10. They're all the same base. They're all common logs, right? You don't have to write the 10 if you don't want to, really. But can you drop the logs like this? No. You can only drop the logs when you have one log on each side and nothing else. So in this case here, what we have to do is get these 2 logs here to be combined into one log, and then we can drop the logs. So we'll take these 2 here, and we'll use the product property. Since this is a plus, we're going to use the product property, which means this is going to be log base 10, which I don't have to write the 10, so I'm not sure why they do that, equals whatever this times this is. So whatever x times 3x minus 5 is. Well, that's just going to be x times 3x is 3x squared, and x times negative 5 is negative 5x. And you get that, right? You get that. Now, they're common logs, so I'm not writing the base 10. And now I can drop the logs. So I'll drop the logs here, and I'll get what looks like a quadratic here. 3x squared minus 5x equals 2. Now, anytime you solve a quadratic, you need a 0 on the end. So I'll subtract 2 from both sides to get that 0 that I need, right? So now it's 3x squared minus 5x minus 2 equals 0. And now the question is, are we going to solve this by factoring, or are we going to solve this by, quadratic formula if it's not factorable? Okay. The one way we can check to see if it's factorable real quick, instead of, like trying because this is going to be AC method. This is not reverse FOIL because the first number is not a 1. So we can't just put, parentheses down and go x and x, because how are you going to get 3x squared, right? So the AC method is, a times c, and you see if, you can find factors that work. But just in case, I'd like to do the discriminant. If you guys remember the discriminant, b squared minus 4ac. If that's a perfect square, then I'll factor. If it's not a perfect square, then I'll use that b squared minus 4ac to do the quadratic formula. So my b is negative 5. It's going to be negative 5 squared, okay, minus 4 times 3 times c is negative 2. And let's see if that's a perfect square. This is going to be 25 plus, because it's 2 negatives become a plus, 8 plus, so 8 times 3 is 24. Yeah, it's 49. Perfect square. That means it is factorable. Okay, the discriminant is 49, which is going to square root of that 7. So I can do, I can do 2 things. I can use the quadratic formula, or I can use the AC method. I'm going to use the AC method only because we haven't used it in a while. Let's see if we can remember how to use it. So a times c is 3 times negative 2, which is negative 6. Can you guys think of 2 numbers that multiply to give me negative 6 that add to give me negative 5? 6 and 1, and which one's got to be negative? 6 is negative, 1 is positive. So we're going to rewrite this. 3x squared minus 5x is going to get split up, okay, into minus 2. This is going to get split up into equals 0. Negative 6x plus 1x. That's how we do that. And then the minus 2 is still there, and equals 0 there. And now what you do is you look at this and you say, all right, what's the GCF right there? What's the greatest common factor for the first two terms here? 3x, right? And then what's left after you pull out the 3x? Looks like x minus 2. And then okay, so you're supposed to look for the GCF of these two here, but you know it's got to include an x minus 2. So if it's going to include an x minus 2, pretty much that's exactly what that is. So there's just a 1 here, okay? And now you have that. And now finally, your factorization is 3x plus 1, x minus 2 equals 0. So you can set these equal to 0 now, and you can get your solutions now. So your solutions are going to be, you're going to subtract 1, divide by 3. So x equals negative 1/3 for the first solution. And the second solution is going to be x equals 2. All right, so we got our two solutions. Now let's check them. If you take a negative 1/3 and plug it into this x here, does that mean you're taking the log of a negative? Yeah, it does. Yeah, what's up? It's positive 1/3? No, it's not. Or did I make a mistake here? Oh, okay. Oops, I did make a mistake. That's a minus here, right? Oh, no, it's not. No, it's not. 3x plus 1. 3x plus 1 is 3x plus 1, x minus 2. So no, this is negative. Okay, so we're going to check this. If you take this and put it into here, that's not going to work. So that's going to be no good. If you take a 2 and plug it into here, that's fine. If you take a 2 and plug it into here, that's going to be 3 times 2, which is 6, minus 5 is 1. That's still good. So this one works for all the logs. You don't have to plug into here. So that's your only working answer. Okay, so now let's try number 3 here. Okay, number 3 is the same situation as the last problem. You have a product here. So this is going to be log base 4 of whatever 5 times x is. So you got log base 4 of 5 times x is 5x. That's the product rule. And this side is log base 4 of 60. Now you can drop the logs. 5x equals 60. Divide both sides by 5. 60 divided by 5 is 12, so x equals 12. And there's your answer. Now check your answer. If you take this 12, do you need to plug it into this log? No, because there's no x. Here it's log of 12, which is absolutely fine. And here you don't have to worry about it. So it works in the only log that you have to worry about. So you're good. Does this mean that 12 is the right answer? No. I mean, maybe 10 is the right answer, right? Maybe I made a mistake. But the point is, whatever I have is at least I know it's not going to violate the logarithms. That's what we mean by check your answer. Because the other way, of checking your answer would be to see if both sides of the equation equal each other. And unless you know what log base 4 of 5 is, which I don't know, there's no way I can check that. Okay, so let's come over here. We got a similar situation here. Same kind of problem, really. Log base 4 of d plus log base 4 of 3. You can combine those using the product rule. Okay, you get log base 3, of d times 3 is 3d, right? Equals 3. Now, there's only one log here. So I can't drop logs, but I can use the circular method. I can go from this to the power of this has to equal that. So 3 to the 3rd power has to equal 3d. 3 cubed equals 3d. I'm going to flip that around. So 3d equals, and then 3 to the 3rd power is 27. And I can just divide both sides by 3 and I'm done. I get d equals 9. Okay. And if you plug that 9 into all the logarithms, you have to make sure it works. Plug in the 9 into this d, you're taking the log of 9, which is fine, it's positive. And this one I don't have to worry about because there's no d to plug into. So that's it. This one's good. Okay, now we go on to number 5. Okay, this one's got a minus. So you're going to use the quotient rule to put these together. Okay, dividing. So log base 5 of y minus log base 5 of 8. That's going to be log base 5 of this over this. So y over 8. And on this side, we have log base 5 of 1. Okay. Now, the logs are the same. We can drop the logs now. So what we get is y over 8 equals 1. And we want to get the y by itself. The problem is the y has a denominator. And the way to get rid of a denominator, multiply by the denominator. So I want to get rid of this 8, multiply by the denominator, and that's going to cancel out like that. But of course, I'm going to do it to both sides. So y equals 8 is our answer here. And now I can just check it, right? If I put an 8 in here, I'm taking the log of 8, which is fine because 8 is a, this one doesn't have a place to plug into. I don't have to worry about it, right? And this one doesn't have a place to plug into, so I don't have to worry about it. So this is good right here. Number 6, we got log base 2 of r plus 2. Okay, so this 2 is keeping me from doing my thing with the, what do you call it? With the combining of logs. So what do I do with it? Like we did in number 1, you just bring it up here. You move it out of the way. You put it back up in the tower, right? So it's not bothering you. And now you can just deal with this. Log base 2 of r plus log base 2 of 5 squared. So that's going to be 25 later equals 0. So now we can combine these, right? And it's going to be a product because that's a plus. It's going to be log base 2 of whatever r times 25 is. So it's 25r equals 0. And now what we're going to do is say this, because there's no, you can't drop logs, there's only one log. This to the power of this has to equal that. So 2 to the 0 equals 25r. Okay, I'm going to flip that around. I'm going to say 25r equals 2 to the 0 because I want the variable to be on the left. Okay, 2 to the 0. What is 2 to the 0? What is anything to the 0? 1, yeah. So what you have here is 25r equals 1. And the last step is to divide both sides by 25. That'll get the 25 out of there. And now you have r equals 1 over 25. Now, it's a positive number. That's all you have to really realize. That positive number, if I plug it in right here, you're taking the logarithm of a positive number, you're fine. I don't have to worry about this logarithm because there's no r. So yeah, this is good. I'm going to box my answer here. Okay, and that was number 6. All right, number 7. We have a similar situation, but this time we have 3 logs. Okay, once again, you cannot drop the logs if there are 3 logs. You can't do that. No, no, no. So we're going to combine these 2 here, but you can't combine while you have a number in front. So if you have any numbers in front, like here or here, bring them all up as powers so they go away. That's the power property of logs. Okay, and now we have log base 9 of 4 plus log base 9 of 5 squared, which is 25 again. You know what? I'm just going to write 25. And this is log base 9 of w. Now I can combine these 2 right here. This is going to be a product because there's a plus here. So I'm going to multiply these 2 numbers here. And I'm going to get log base 9 of 100 equals log base 9 of w. And I can drop the logs and I'm done. W equals 100. That's it. So once again, check your answer. Do I plug the 100 into here? No, there's no w. Here? No, there's no w. Here? Yes. And if I did that, I would have log of 100, which is fine. So yeah, I'm going to box my answer. Okay, number 8. Okay, this time we have a quotient rule because there's a minus here. All right, and if you take the log base 4 of this over this, you get a fraction, right? You get n plus 1 on top and n minus 2 on the bottom. So that's the quotient right there, equals 1. So now that we have that, we're going to use, we only have 1 log now. We have to use a circular method because we can't drop logs. So 4 to the power of 1 has to equal this fraction. So basically this fraction equals 4, right? So you have n plus 1 over n minus 2 equals 4. Now, once again, the problem is that this is a fraction. Okay, fractions are a pain in the butt sometimes. So the way to get rid of fractions is to get rid of the denominator. The way to get rid of a denominator, you multiply by the denominator. We did a few minutes ago with the 8. This time it's n minus 2. Not a big deal. Just multiply this by n minus 2 on both sides. The n minus 2 here will cancel out the n minus 2 here. No more fraction. Now you have n plus 1 equals 4 times n minus 2. Let's distribute this while we're at it. This becomes 4n minus 8. And now what you have is an algebra 1 equation that you have to solve, right? So we got n plus 1 equals 4n minus 8. We'll get rid of the smaller of the 2 n's. So I'll get rid of this n right here by subtracting it from both sides. That's gone now, right? This is 1 equals 3n minus 8. What else can I do? I can add 8, right? To both sides. That becomes 9 equals 3n. So divide both sides by 3, n equals 3. Okay, so now come take that 3 and go into every log and see if it works. If you put a 3 here, you're taking the log of 3 plus 1, which is 4, which is fine. If you put a 3 here, 3 minus 2 is still positive 1, and that's okay. So that means the 3 is good. You can use that. All right. All right, let's move on to number 9. Okay, now in this section, we're solving exponential functions. So all the ones we did in 1 through 8 were logarithm equations, and this time it's going to be exponentials. And the problem with exponentials is there's no properties of exponentials like there are properties of logarithms. There's no quotient rule, there's no power rule, there's no product rule, that sort of thing. So one of the main strategies, we're going to use one of two strategies here. We're either going to find bases to match, or we're going to take the log of both sides. That's just going to be a summary of what we're going to do. Like for number 9, there's actually 2 ways you can do number 9. Okay, if you use the base matching thing, you'll realize 3 and 243 have a common base. They're both powers of 3. Okay, so this is a 3, but this right here, this is 3 to the, let's see, 3 to the 3rd is 27, 3 to the 4th is 81, 3 to the 5th. This is 3 to the 5th power right here. And if you can find a common base, just drop the bases and you get x is greater than 5 and you're done. Okay, and you put it on a number line. Okay, there's 5. There you go, like that. So that's the easier way to do that, matching up the bases. And you can do that sometimes. You can't do it with 11 down here because 8 and 50 have no common, number that you can you can use as a base. But 3 and 243, I just happen to know that 243 is a power of 3. If you don't know that there's a common base, what you would have to do is take the log of both sides and do what we're going to do for all the rest of these problems. So let's see what happens when you cannot find a common base. Let's look at number 10. Now you have 3 and 4.1. These don't have a common base. Okay, no good. And also it's decimal, so you're probably going to have to take out a calculator at some point. So if you can't match up the bases, your only choice now is to say, all right, well, I need to bring this power down so I can get the r by itself. I can't bring the power down because it's not a logarithm. So how do I make this a logarithm? I take the logarithm of both sides. Take the log of the left side and take the log of the right side, like that. Once I do that, that opens up the possibility for me to take this and bring down the power, okay? Now be careful, this is 2 terms here, so when you bring it down, make sure you use parentheses, okay? So it's gonna be r minus 5 in parentheses, like that, log 3, and then this side here didn't change. And now your job is, how do I get this r by itself? Here it is. I need to get rid of 2 things. I need to get rid of this log, and I need to get rid of this -5. The log, I'm going to divide. Divide both sides by log 3. That'll cancel out the log, and that'll get me there. Now I have r minus 5 equals this fraction right here, which is going to have to be done with a calculator. Well, I want to get rid of that 5. How can I get rid of this 5, this -5? Yeah, I can add 5 as well. So if I add 5 to this, if I put a +5 here, that'll cancel out that 5 right there, right? And that means I have to add 5 over here as well. So r equals whatever this fraction is plus 5. Now you reach for your calculator. Okay? So we grab our calculator. We want log of 4.1 divided by log of 5. So log 4.1, close parentheses, divided by log of 5. Okay, there it is. Hit enter, and then I'm also going to add the 5 that we have to add at the end. And we get 5.87. I think they want 4 decimal places. So 5.87669 is 5.8767. 5.8767, and there's your answer. Now, do we need to plug it back in like we do with the logarithms? No, only logarithms make you do that. So unless I made a mistake, I should be fine. So I actually had the wrong log in there. I used log of 5. So let me just go back. I'll just fix that. All right, the right answer is 6.2843. Okay, there you go. All right, next one here. Once again, if you can match the bases, you can do that, but most of these are not going to be base matching because most of these bases don't match. So with 8 and 50, there's no number you can use as a common base, so you're going to have to take the log of both sides. So we'll take the log of the left and the log of the right, and the rest of it remains the same, like that. And now because we have a logarithm, we can take this power of p here and we can bring it down, put it in the front. So now this is p over here, log 8 equals log 50, all right? And last thing for me to do is get the p by itself by dividing both sides by log 8. That cancels out, and that's my answer right there. P equals whatever that fraction is. So with the calculator, log 50 divided by log 8, log 50 divided by log 8, and we get 1.8813. All right. And now be careful. It's two separate logs. It's log 50 divided by log 8, not log 50 over 8, like in one thing. It has to be two separate logs, one log divided by another log. Okay, next up is number 12. Okay, 7.6 and 57.2, definitely no common base there, right? It's all decimal. So we're going to take the log of both sides. You could change this into a logarithm with the circular method, but I think that would be more complicated here. So taking the log of both sides is probably your best bet. So log, all right? This side is 77.6 d to the 3, d plus 3 equals and 57.2. Okay, so taking the log of both sides. We can move this d plus 3 power down using the power property of logarithms, right? And now in parentheses, careful not to forget the parentheses, you get d plus 3 log 7.6 equals log 57.2. Now, my job is to get this d by itself. So what I'm going to do is get rid of this log first by dividing by that log. So that gets rid of that. And that gets rid of that. I also have to get rid of this plus 3. So how can I get rid of this plus 3? Minus 3, right? So I need to subtract 3 from here. So I'll do that by just putting a minus 3 on this side and a minus 3 on this side. That'll take care of, those will cancel out right there. So now I got I could have done it in 2 separate steps, but to save space, I did it in one step. All right, so now I just have to take the calculator, find out what this is, and then subtract 3 from it. So grab the calculator, log of 57.2 divided by log of 7.6 equals that, and then subtract 3, right? We subtracted 3 from both sides. So what I'm getting is negative 1.0048, and that's that. Okay, moving on to number 13. All right, so number 13, we got ourselves another situation where the bases don't, it can't be matched because there's no common base for 5 and 106. So I'll take the log of both sides, log. The rest of it remains the same. And now I can bring this 3b down using the power property of logs. I can bring that down. So now I got 3b log 5 equals log 106. And now my job is to get that b by itself. So I have to divide by actually 2 things here. I have to divide by log 5, but I also have to divide by that 3 there. So I'll divide by 3 log 5. That'll take care of both. And just the b will remain. Okay, so this side I'm divided by 3 log 5. So what would that look like in the calculator? I'll get the big screen out here. I want log 6 divided by 3 times log 5. So here's log 6 divided by, and then in parentheses, whenever you have more than one thing inside of a denominator, I like to put parentheses around it, 3, and then log 5, like that. And then close parentheses twice, right? 2 open, 2 close, and that should do the trick. 0.37109, so 0.3711. Oh, where did I get 6 from? Log of 106. Hello. So I need to go back and fix that. Okay. 0.965. Okay, number 14. Okay. We're going to take the log of both sides because there's no common base here. So log. This is going to be 42x squared. 42 to the power of x squared, rather. And 84. I can bring down that x squared using the power property down here. And now it's x squared log of 42 log of 8 equals log of 84. And now my job is to get the x by itself. So I'll divide both sides by this log right here. Log of 42, both sides. And that gives me x squared, x squared equals this thing here, right? So how do I get the x? If I want the x, I need to square root both sides. So x is going to equal the square root of whatever this is, log 84 over log 42. Okay. And well, technically, if you square root the x squared, you get absolute value of x. So this will be a plus or minus. And I think that makes sense because if you plug in any number, whether it's positive or negative, once you square it, it becomes the same thing. So there should be a plus or minus in this answer here. But anyway, let's get the calculator and see what that number here is going to be. What is the square root of log 84 over 42? So big screen so you can see what I'm doing. First thing I'm going to do is open the square root part of the calculator. So that would be that. And then inside the square root is going to be log 84 over 42. 84, close parentheses, divided by log of 42. Okay, and hit enter. I'm getting 1.08878, so 1.0888. And like I said, it's plus or minus. I'm not going to worry about plus or minuses on the quiz tomorrow, so don't worry so much if you forgot the plus or minus part. Okay, 16, we're almost done here. Down to the last few. Log of both sides, bring down the 7p, get rid of the log 12 that's on the left. We want to get rid of that. And we also want to get rid of the 7. So we'll divide by log 12. That'll get rid of that. We'll divide by 7. That'll get rid of that. So this is going to be 7 log 12 over here on this side. So that's what our p is. Our p is whatever log 120 is divided by 7 log 12. And that's when you reach for your calculator, you do all that. So log 120, close parentheses, divide by, and since the denominator has multiple things in it, I'm going to open parentheses for the denominator, 7 log 12, close parentheses, and I'm getting 0.2752. 0.2752. Okay, 16. Oh, there's going to be a quadratic in this one. Okay. You might think that 5 and 10 have a common base, but there's no power of 5 that gives it 10 without going into decimals. So now there's no common base here. It looks like it is, but there isn't. So we're going to take the log of both sides. So log of 5x to the x squared 1/2, and then log 10 on this side. Okay. You might notice that I'm taking common logs on both sides here. These are both log base 10. So log base 10 of 10 is a 1, right? Because technically this is a 10 right here. So if I want to, I automatically know that this is a 1, and that's going to save me a little bit of trouble with the calculator. So how about I just go ahead and realize that, hey, this is log base 10 of 10. That's going to be a 1. And then here I can bring down the x plus 1. Don't forget to use parentheses now. The x squared plus 1 comes down, and now I have log 5 here. So x squared plus 1 is going to be 1 over log 5. Oh, this is going to be a mess. Well, no, it's a simple quadratic. Maybe it won't be too bad. So I think at this point, I should just find out what this is in decimal. What is 1 over log 5? 1 divided by log 5 is 1.4307. So what I have here is x squared plus 1 equals 1.4307. And now I'm going to subtract 1 from both sides. So I get x squared equals 0.4307. And now I need to square root both sides. And that's going to give me a plus or minus answer once I do the square root. So plus or minus whatever the square root of 0.4307 is. So square root 0.4307. And what I should have here is 0.6563. Once again, I'm not going to hit you on the head for the what do you call it, the plus or minus, if you don't do that tomorrow. All right, this last section is just a couple of quick things using the change of base property. They want you to find log base 3 of 7 with the calculator, but your calculator doesn't do base 3. So you use the change of base theorem. You change this into 2 separate logs, 1 log of the big number divided by 1 log of the little number. Really simple. So just take the log of the big one over the log of the little one and use your calculator to get the decimal approximation. And that's how it works for 17 through 20. So we'll just do that real quick here. Log 7. I'm putting in extra zeros just so I can reuse this thing. over log 3. And what I'm getting here is 1.7712. There you go. That's 17. Now for 18, this is going to be split up into log of 66 on top and log of 5 on the bottom. So all I have to do is go back into my calculator and just change those numbers to 66 and 5. And I get 2.6032. There's that one. How about 19? How do you rewrite this one? Once again, change the base theorem is really simple. Just take a log of the big number, divide it by the log of the little number. So 35 over 2. Go back into my calculator, use 35 for the top one and 2 for the bottom one. And I get 5.1293. And then finally, number 20, the last problem for your quiz, log of 10 over log of 6. Now, log of 10 is 1. Log base 10 of 10 is going to be 1. But you know what? Since I already have it set up in the calculator, I'll just put in 10 and 1, 10 and 6. Why not? So 10 log of 10 divided by log of 6. And what I have here is 1.2851, and we are done. Okay, now we're into the honors section here. So this is 21 through whatever. Let's see. It says write an equivalent exponential or logarithmic equation. So basically, don't solve for x, just write an equivalent. If it's an exponential, write a log. If it's a log, write an exponential. So this is a log right here. This is log base e. This is a natural log, right? So it's e to the power of x has to equal 15. There's your exponential equation. So e to the x equals 15. Next one, 22. Once again, this is a natural log. So for a natural log, your base is e. So it's e to this power is approximately equal to that. So e to the power of 0.6931 is approximately equal to x, or x equals that, either way. All right, and that was 22. 23. Now you have an exponential you want to write as a log. So the way that works is you start with log base this of whatever's on this side of the equation equals whatever the power is here. So log base e of this equals this. So what you have here, if you want to write it literally first, it's log base e of x minus 3 equals 4, but log base e is natural log. So this is ln of x minus 3 equals 4. All right, next one is 24. Another logarithm. So once again, this is the log base e. So it's this base to this power equals this decimal. So we have e to the 2x equals 5.34. All right, next section. Write as a single logarithm for the next 4 problems. So we're just going to be combining logs. Now the rules for any logs, the four properties of logs are the same for logs that are of any base. So natural logs are no different. I like to combine these 2 logs. I can't do that until I get rid of this power right here. This power needs to come up and get out of the way and end up here. So the first thing I need to do, the first step here, if you're looking at this as a quiz question, the first point is ln base 3 of 3 to the third, ln of 3 to the third rather, equals ln 9. That's your first point for getting that 3 out of here using the power property of logs. And then the second thing would be using the quotient property to turn this into a single logarithm. So ln of this over this, right? Now this 3 to the third is 27 over 9. And of course you have to simplify things. So that would be the second point, by the way. You have to simplify whatever you have here. So 27 over 9 is 3. So ln 3 is your final answer. So that's 25 written as the simplest form of a single logarithm. Okay, number 26. Once again, we have a number, a power sitting in front of the logarithm that's blocking us from using the quotient rule. So we'll bring it up here, right? And your first point is ln 16 to the 4th minus ln 256. Now, this is a quotient rule. So this is going to be ln whatever 16 to the 4th is over 256 is. So there's your quotient rule. That's second point. Now for simplifying, 256 is 16 squared. So really what this is here, All right, and maybe a calculator would help you with that if you didn't know that. This is 16 to the fourth over 16 to the half. When you have two of the same base, what do you do with the powers? Like if you had x to the fourth over x to the second, what do you do with the powers? Subtract. Well, here in this case, x just happens to be 16. That's the only difference. So you're going to subtract the powers. As long as the bases are the same, you can do that. So this is going to be ln 16 to the 2, also known as ln 256. So that would be your final answer right there. Okay, number 27. Okay, we want to combine these logarithms, but both of them have a constant multiplier. So both of them need to get their constant multipliers removed and put up here like that. Okay, so now you have ln x squared equals ln 4 squared. And since you have a ln equal, well, we're not, yeah, we are solving. No, we're simplifying it to one. What am I doing? This is not equals, this is plus, sorry. You're not solving, you're combining. So now we have a plus here, so this is going to be product rule. So this is going to be ln whatever x squared times 4 squared is, that's 16x squared. So I can put parentheses around it, or I cannot put parentheses around it. It doesn't matter because it's all one term. So there you go, ln 16x squared. Now, if you look at it, this can also be thought of as something squared, right? This can be thought of as ln 4x, the whole thing, what? Squared, right? And if you wrote it this way, what would you now be able to do? You could bring down this 2, and now you would have, because you could use the power property here, and bring down that 2. So this would be a more simplified version of the same answer, yeah. This would be 2 ln 4x. And then you can say, wait, isn't 4 2 squared? Well, let's not get into that because now you have to separate this. So now I think we'll leave it at this because the x is not going to be squared. So that's as good as it gets right there. And yeah, if you see the opportunity to do something like that, I would definitely do it just to make sure you get your full credit. Okay, so there actually is another alternate route that you could have used. Since both of these have the same 2 here, you could factor out a 2 in theory, right? And what you would have here is 2 times ln x plus ln 4. If you factored that out, this then becomes ln 4x right here. And you get the same answer that we got here. So yeah, if you factored out the 2 in the beginning, it kind of saves you from putting the 2's up and then later bringing the 2 down. That actually is more efficient. And it does work, yes. Okay, number 28. Okay, and actually now that I'm looking at this one, this also has the 3 and a 3. We could use that trick and factor out the 3's this time, right? So that'll save us a little bit of trouble. And actually, there's a 4 there. And what is a 4? 2 squared, right? So check this out. We're going to factor out the 3 from both of these. And now we have ln 4 plus ln 3 in the parentheses. Yes? You guys follow that? Now, this 4 right here is a what? It's a perfect square. Well, I was going to say we could write this as 2 squared and then bring down the 2. But for the purposes that we're trying to do here, we're not going to do that because if we brought down the 2, right? If we made this ln 2 and then 2 here, we can't combine. We'd end up moving it out of the way. So let's not do that. Let's just go ahead and combine these. So this is going to be 3 ln 12. And we'll stop at that. Parentheses optional on the 12. But I was going to say, if your final answer was ln 4, ln 4, that's ln 2 squared. So you write it as 2 ln 2. You wouldn't leave it as ln 4. But 12 is fine. Yeah. Okay, number 29. These say solve the equation or inequality, round to the nearest 10,000th, so 4 decimal places. Okay, so your goal with all of these, if you're solving an exponential or a logarithm, is to get that thing by itself, right? So the first thing I want to do is get the e by itself, and then after that, I'll deal with getting rid of the e. So let's see. I'll subtract 3 from both sides first. I'll get that. I'll divide both sides by 5. And now I have e to the x equals 3. And now the question is, how do I get x by itself? Well, I need to bring the x down from where it is. So I'll need to take the log of both sides. Now, here's the thing. If you're not paying attention, you take an log log, you're going to make life difficult on yourself. What's the best kind of log to take if you're dealing with an exponential? An e, I mean, a natural log. So make this ln e, ln 3. Ln e, actually what? Yeah, you bring down the x, and this becomes a 1. So really, ln e to the x is just 1. Equals ln 3, and you can box your answer. Ln 3 is a decimal. You know, like I said, in calculus, I would take off points if they turn into a decimal. Actually, this would be a non-calculator problem, so they wouldn't have a chance to take the decimal. Ln 3 is exact. If you put it in your calculator, you're going to get some crazy decimal that you have to round. Oh, no, wait. They told us specifically get 4 decimal places, right? Okay, so I'm just saying, normally you would stop here, but because they specifically say go to 4 decimal places, we're going to do it. Okay, it goes against my instincts to do that, but I'll do it because they told us to. So ln 3 is 1.09698661. So we'll take it to the nearest 4th decimal place, 1.0986. And that should be the answer that you get for number 29. Okay, ln 3 is what I would expect from, on a test or a quiz, but this worksheet is saying, go to 4 decimal places. All right, next one, 2030. Ln 8x equals 3. You can't drop the logarithms because there's no logs on both sides. So basically it's a circular method, right? So what's the base of this ln? E. So you're going to say this to the power of this equals this. And we get e to the third equals 8x. I want to get x by itself right now. So my job is to get the 8 out of here. So what I get is x equals e to the third over 8. Now, e is a number like pi. It's not a variable. Okay, so this is an exact answer right here, but they don't want the exact answer. They want the decimal approximation. So I'll grab a calculator and find out what e to the third divided by 8 is. E to the third power is that decimal divided by 8, 2.510, and then the 6.9 becomes a 7. And there you go. So like I said, when you get to my AP Calc class year after next, I'll ask you to stop there. But for the purposes of this worksheet, they're telling you to go to the nearest 10,000th. You can change to a decimal. Okay, let's take a look at number 31. So we have e to the negative 4x is greater than 10. Whenever you have an e, you want to take the log of both sides. Well, take the natural log of both sides, right? So this is going to be ln of this side greater than ln of this side. Now, what's good about this is that we can bring down the 4x and then make this into a 1. So this essentially just becomes 4x. And this is a number right here, ln 10. It's not 1. Log 10, log 10 is a base 10. That would be a 1, right? Ln 10 is some other number. So you don't want to just think that this is going to be a 1 like it would be with a normal log. But we could also divide by negative 4. Now, when we divide by negative 4, that's D-band. But to divide this by negative 4, this inequality will flip. And this greater than becomes a less than. And now the question is, what is ln 10 over negative 4 or negative ln 10 over 4, like that? And we can go for our calculator here and figure out what that is. So ln 10, make sure you use the natural log button on the calculator. Okay, divide that by 4 and slap a negative on it. So what I'm getting here is x is less than negative 0.5756. Okay, and on a number line, that's going to be an open circle shade to the left. So this one's got a single log here. There's actually, okay, so there's 2 ways you can handle this. And this, I haven't shown you this that much this year, but this is actually something you could do. So I'm gonna do this problem twice without any worries of weird results because I know both of these work. Now, what I've been telling you to do with one single logarithm is this. I've been saying, take the base and go this to the power of this equals this, right? So e to the 1, which is just e, equals x plus 3. So we get x plus 3 equals e. We subtract 3 from both sides, x equals e minus 3, and we're done. All done. Okay? Now, if we check that answer, e minus 3 plugged in here, e minus 3 plus 3 is e, and log of e is fine. So it works out domain-wise. Another thing you can do, you know how we take the log of both sides of an exponential? You know how we do that? Another thing we do in calc kind of frequently, so I want to show it to you, is that instead of taking the log of both sides, you can take both sides as the power of a base. Meaning, check it out, you could say, let this be the power of e, and let this be the power of e, like this. So now we have e to this equals e to the 1. Now, what happens there? This is the base property of logarithms now. The e and the ln cancel out, and this just becomes x plus 3. And this is just e. And you get the exact same answer. Okay? So there's 2 ways you can do this. They both work. You can take the log of 2 sides of an equation, or you can make both sides the power of something. So just in case that's not really clear. Let's say you had log base 5 of x equals 10. Okay? You could say, all right, I'm going to make this a power of 5 and this a power of 5. These cancel out, and I get x equals 5 to the 10. Okay, you can do that. You can put a base underneath an equation as long as it's one thing equal to one thing. It's the equivalent of taking the log of both sides. It's taking the exponential sort of both sides. You're making each side the power of an exponential. Okay, and this makes sense because 5, if this is equal to this, then 5 to the power of this has to equal 5 to the power of that. Okay, so that's just another trick, another way to do this problem. You can do it either way. I'm probably thinking you're going to stick to the circular method, but this is also a shortcut as well. Okay, and yeah, technically they did tell us to round to the nearest fourth decimal place, so we need to grab a calculator and do e minus 3, which would make it x equals negative 0.2817. Okay, and that's number 32. Number 33. Okay, once again, you want to get the e part by itself before you do any tricks, right? So we'll subtract 1 from both sides. This becomes negative 2e to the 2x is less than or is equal to negative 20. We'll divide both sides by negative 2. So now we get e to the 2x equals 10. And this is the point where, you know, you need your trick now. So taking you can have two options, like I said before. You could say log base this of this equals this, or you just take the log of both sides, which is the one that I would go with. So log in this case should be a natural log because it's an e, right? So you want to take ln of this side equals ln of this side. The lns cancel out, the 2x comes down. You get 2x equals ln 10. So x equals whatever ln 10 over 2 is. Now there's your exact answer. And for your decimal approximation, ln 10 divided by 2 is 1.1513. And that is number 33. And the last one in the honor section, this one right here. So you want to solve this equation here. You got two logs. You're going to have to combine them using the product property, right? So this becomes ln whatever x times 2x is. That's 2x squared equals 2. Now, once again, there's two ways to do this. And I'll show you both ways. Okay. The way that you probably most familiar with is to say that's an e. So this to the power of this equals this. So 2x squared equals e squared. Divide both sides by 2. X squared equals e squared over 2. Square root both sides. X equals the square root of e squared over 2. Okay. Now, is there a plus or minus? I'm not going to worry about that for this quiz here, but that would be the exact answer. Now, the other way is to say, well, let this side be a power of e and this side be a power of e. These cancel out, and now you have 2x squared equals e squared. And if you notice, they're exactly the same. I'm in the same exact spot here. So either one of those methods will work. And then this in decimal is going to be the square root of e squared divided by 2, which is 1.9221. Okay, we're done. See you at the next video.
Check this.